Let's continue our discussion by looking at processing as well as some of the devices that we require in order for telecommunications to function. Now, we basically get three types of processing, namely centralized, decentralized, and distributed processing. And if we look at each one, it all comes down to various locations, it comes down to security and the way in which we want to allow processing over our network. So if we look at centralized processing, we will see that all the processing typically occurs in a single location or facility. This offers the highest degree of control because we've got a single computer that manages all of the processing and our data and information. Now, examples of these would include companies that want to secure the information, companies that do perhaps research. So these companies typically wouldn't want others linking up with their networks using their processing environments, and they want to make sure that all of the information is typically protected and that they use the resources to its full capacity. The next type of processing that we find is decentralized processing. Now, with decentralized processing, processing can actually take place at various remote locations. Each of these systems are isolated and they do not need to communicate with any other systems. And these are typically companies that have various independent units. For example, if we think in terms of companies such as Microsoft, they might have a unit developing new hardware or devices, and they would perhaps have a unit developing software, application software, as well as one developing new operating systems. So each of these three units will do their processing by themselves, not worrying about the other units. The last example that we do find is distributed processing. Now, with distributed processing, devices are placed at remote locations. However, they are all connected with the network. So managers can typically go and they can look at the processing capabilities that are available, and if they find that, let's say for argument's sake, a unit in another country have a lot of processing, they can issue the commands to that unit and the processing will occur at that remote location. These types of processing or distributed processing is also very nice where we have situations where disasters occur. So if something happens to your particular region and processing cannot take place, you can ensure that processing takes place at some of your other branches without interruption to business and your ability to conduct transactions, etc. So with distributed processing, we do find that it offers us uninterrupted system availability. And many of the bigger companies would actually opt for distributed processing. Now, when we look at the basic processing alternatives, it's important to know that we have an idea of what goes on underneath each one of these, but that we also have the capacity or the capability to apply to real world examples. For example, we can tell you guys we've got a company, we've got 6 different departments. Each one of the departments has distinct characteristics or requirements, and each of them need to worry about processing by themselves. Then you should know that we should use decentralized processing. Alternatively, we can say we've got a company that need to work with secure data, so they're busy with research, they don't want other people to find out what they're doing. What type of processing would you recommend? And in that case, it would probably go over to centralized processing, where we want to control it in a single facility. Last case example, distributed processing. Imagine that you a bank, so if anything happens to one of your branches, the rest of the network should still function correctly. Or if there's a disaster in one area, that people will still be able to use your resources by looking at, let's say, competitors' networks. Now let's continue and talk about client-server environments. Now we're going to have two components. We're going to talk about clients. Now these are typically all the people that link up to company mainframes. So we would find that we've got client computers, and these computers would be linked to a server. Now we're going to go and look at these in a little more detail. Client server environments typically are found in larger companies where a lot of the data and resources are placed on server computers, and where the employees and suppliers need to actually link up to these server computers in order to access the data or to use the resources. Some examples that we find is typically database management systems, where you've got a server and your databases or your information is saved on that server. So anybody would link up to that server in order to gain access to the information. For example, if you want to withdraw money from your bank account, the bank records, your banking details, would be saved on a server, and whenever you go to a bank or you go to an ATM machine, those would be considered your client computers, and they would link up to the bank server, and you will gain access to your information. Some other client server type environments that we do find is printing, where you've got good quality printers and you've got a lot of client computers linked up to those printing resources. We've got communications, and we've got program execution. So communications relate perhaps to having access to internet. So you would have a computer that's connected to the internet, and it would distribute the resources evenly amongst all the clients that need access to internet resources. So let's go a little more into detail and talk about what is a client. Now typically a client can be defined as any computer, in many cases uses PCs, that sends messages and requests services from the server on the network. So you would send requests to the server, or you would send messages to the server, and the server would actually fulfill your services. For example, if you want to access the internet, you're going to send a message and you're going to say, I need access to the internet. It's going to grant you such access, and you will be able to access internet resources. If you want to make use of shared resources, such as, for example, printers, again, the server would issue the service to you, and printing would be able to take place. If we look at the server computer in a little more detail, servers can technically be categorized as any computers of any size that is situated over a network that has various dedicated functions. Now, some of the examples that we typically find is application servers, where you got a server that issues applications to all the employees within a company. So instead of a person to go and buy software packages for, let's say, 800 computers, they can just distribute it over the network. Licensing agreements would have been agreed upon, and the server would ensure that the latest versions are actually installed on the client computers. Some other typical examples we do find is email servers. Now this is where, for example, we make use of services such as Gmail. So you would be considered a client. Google would have various servers, email servers situated in their facilities, and you would link up to those servers and make use of your email messages. Another example that we find is web servers. Now, whenever you access a website, that site is hosted on a web server. So if we think about UWC, the UWC website would be hosted on a computer somewhere on the UWC grounds, and whenever somebody types in that address within the browser, it's going to link up to that server computer, and it's going to load the pages from that computer and display it on the client's computing devices. Now let's continue and talk a little about telecommunications hardware. Now we do get various examples of this, and for some reason it can be quite confusing because it's a little abstract. You haven't worked with it, you haven't seen it in real life, but there are specific functions for each one of these types of devices. Now we're going to start off with perhaps the easiest one of them all, smartphones. Now smartphones actually combines the functionality of various devices such as your traditional camera, your traditional phones, web browsers, emails, tools, MP3 players, file systems, etc. So all of these are combined and it allows you to actually access various internet or network resources. The next popular one is modems. Now we've spoken about modems when we started this topic discussion. Now we said a modem actually means, or the word modem means modulator, demodulator. So what's going to happen is it's going to take the data which is in digital signal format, it's going to convert it into analog signals, transmit it over a medium, let's say the wires. On the other side, it's going to accept the analog signal and it's going to convert it back to a digital signal which will be recognized by the computer. Now just to recap shortly, analog signals are typically any sound waves. So if you think about a traditional telephone system, these would have been the sound waves traveling over the telephone lines. Computers works with ones and zeros, so they work with digital signals. So we need to have a method where we actually can change between digital and analog signals. Now, for example, if you think about pressing buttons on telephones and mobile devices, you might have heard those different or various ringtones, or not ringtones, those sounds. And those are actually the conversion between analog and digital sound waves. The next one we're going to look at is fax modems. Now, this is a popular device, especially in companies, where they combine fax capabilities with a modem, allowing people to gain access to perhaps telephone conversations, but also to send fax messages over that same medium. Fax messages at this stage is becoming perhaps less popular due to the ability of people being able to scan in documents and rather send it through email communications, etc. The fourth device we need to look at is known as a multiplexer. Now with traditional systems, remember we've spoken about broadband and the amount of data that could have been sent over a medium, and that's typically measured in hertz and gigahertz. So for a particular medium, you're only allowed to send a certain amount of information over it. Now if you imagine having a telephone line and only one person can use it, it would mean that the rest of the people linked up to that medium will not be able to send any information. So a multiplexer will actually take various signals. It's going to give equal amounts of time for each one of those signals, and it's going to send it over the same medium. On the other side, it's going to listen to the message, it's going to break it up, and it's going to distribute it to however number of signals was actually sent into this particular medium. So for example, if we look at this particular device here, it allows you to have 4 cables connected to it, so there can be 4 different messages being sent. It's going to take the 4 messages, it's going to give equal amounts of time to each one of those. They will be sent out over that single output. On the other side, it's going to be accepted into a single output, and then it's going to distribute it again into the 4 individual messages. The next device that we're going to refer to is known as your PBX, or your private branch exchanges. Now these are typically where you've got a few telephone lines going into a building, but it actually uses those lines and it actually generates or creates additional telephone lines and numbers. For example, if you think about UWC, let's say for argument's sake UWC has 4 telephone numbers, official numbers, meaning that there's 4 lines going out of the company. However, internally, if they make use of PBX, they can generate a lot of extensions, assign extensions to the different employees, and people will use those 4 lines in an optimal manner. Then we get our front-end processor. Now the purpose of a front-end processor is actually to manage all the communications that comes and goes from a computer system. So any messages that comes in, it's going to look at the messages, it's going to ensure that it's allowed into the network, and then it's going to send it along to the correct people. We're going to continue and talk about a switch. Now, a switch is typically the device that is used in star network topologies, where all of the devices are connected to that central device. So a switch would have various ports. So all the computers, the nodes, would be connected to the ports. So whenever a computer sends a message to another computer, it's going to send it to the switch. The switch will determine which port should receive the output, and it will redirect the information to that particular port, which in turn will send it to the destination computer. The last three devices that we're going to look at is bridges, routers, and gateways. Now, a bridge is actually a device that will connect various networks to each other. What we need to know is that a bridge and a gateway is actually very similar type devices. So a bridge will typically connect two, let's say in this case, LAN networks to each other. And these networks should make use of the same telecommunication protocols. So let's say this would be a bus topology and that would be a bus topology. So it's going to allow a linkage between those various networks. So a bridge will inspect the incoming traffic, and then it's going to decide, okay, should it be sent to the next network? If it was intended for that network, it's going to pass it along. If it was perhaps intended for another network, it's going to redirect it to that other network. Now, before I'm going to talk about a router, I first want to speak about a gateway. A gateway is any network device that serves as an entrance to another network. Now, typically it has the same function as a bridge. The only difference is a gateway can actually change between various different network types or topologies, and it can actually handle various protocols. For example, if you send a message from a ring network that makes use of a token, and you want to send it to a bus network, the gateway will accept that message and it's going to distribute it to the bus network, ensuring that it's sent to all the recipients within that network. Okay, so it looks at the different protocols and it makes changes if it's required. The last device that you need to know about is a router. Now, routers typically work with data packets, and these data packets will be forwarded amongst the different networks that's connected to it. This is also known as routing. So we would have various distinct networks. These networks would be connected to a router, and whenever information is sent in the form of packets, it would be routed to the intended destinations. Now, for the last section for this particular discussion, we're going to continue and talk about telecommunications software. Now, telecommunications software can typically be found in a few versions. First of all, we need to talk about network operating systems. Now, if you think back to chapter 2, we said that system software are those applications or programs that enable hardware devices to communicate with each other, and also for users to communicate with a computer. Now, if you want to work with a network, you also need an operating system in order to run and manage all the network resources. So a network operating system can be defined as a system that controls the computer and all of the devices on that particular network. And it's also going to allow these devices to communicate with each other. Now, we do get it in two variants. You get the more complex version, which is your network server operating system. So if you guys think back to our discussion on client-server environments, you need to have an operating system for the server, which is a little more complicated. And then alternatively, you also need an operating system for your client devices or your workstation devices. Now, the software that should be installed on the network servers, they will typically look at user accounts, assigning user accounts. When people access information, they will make sure that they're actually allowed to do so. It's going to enforce security mechanisms, authentication, allocating resources to different users, to different computing devices, etc. If we look at the smaller portion of the network operating system, the one that's being installed on your workstations or your clients, these typically allow people to connect to the network so that they gain access to network resources and that they have the ability to communicate with your server. Now, going together with network operating systems is network management software. Now, network management software, the whole idea behind it is it can allow administrator to monitor the use of individual computers and shared hardware. So let's say, for argument's sake, you're responsible for the network. Then by using network management software, you can go and look at all the applications that's installed on the different clients. You can go and see what information they're using, when they're using it, whether they have the necessary access rights, etc. It's also going to scan for viruses. Nowadays, it's important to ensure that our networks function optimally. So viruses such as worms and trojans, which typically slow down your network, will be detected, and these types of encounters would be blocked. The third important function of your network management software includes being compliant to software licenses. From time to time, you hear about companies that's using illegal software and they get hefty fines. So by having network management software, as soon as somebody tries to install software that they're not allowed to have on those devices, the system can pick it up, it can send a notification to the user and even to the administrator, ensuring that compliance is enforced. Now, what's the nice thing about network management software? It actually makes the life of the network administrators a lot easier. They can easily go and update files and programs on the network, so you just issue a command and that would be enforced down to all the client computers. You can protect your software from being copied or modified illegally. Whenever there's problems or errors on the network, these issues can be detected and sorted out. And it also enables the manager to go and connect to desktop computers and technically to any network resource or nodes on the network. And this is actually known as software defined networking, or SDN. Now, in the older days, whenever you worked with a network, let's say for argument's sake you were responsible for maintaining and running the network, you had to go to different network nodes to ensure that the operating system was installed, that necessary network programs were installed, and that all the devices were functioning optimally. Nowadays, by using SDN, we can actually have a controller connected to the various devices, so the network administrator can sit in his office, they can communicate to the controller and issue commands to any node on the network. So instead of the person going around ensuring that all nodes are connected, the necessary software is installed, the commands can be issued to the controller and the controller will redirect the commands to the various devices. This concludes our topic discussion about client-server computers, some of our network devices, and in our next section we're going to talk about the internet and what is the internet.